Okay, something caused my camera to cut off. So let me pick up sort of where I left off. I was just walking over to get some alligator clips. We have some here. There's some with red and some with black. And there's another tray of them here where you can put whichever color you want on them. So those will probably be laid out more neatly when you come to the lab. But what we're going to try to do here is let's use the darker colors matched up. I have to do this off camera. I'm just going to slide this over here. Okay, so I've got that on there. And let's put the red one on the lighter color. Okay, so we've got those. Let's match colors here. That's important to keep track of things. And so we're going to go ahead and I'm going to turn off the power supply. Notice it's at 5 volts, but I can turn it down to 0. But the safest thing is really just to turn it off. And then I can plug the white cable with the red end into plus and the blue cable with the black end into minus. And then I can hook up the circuit. All I have to do is clip the alligator clip directly onto the resistor legs. So now I've got a complete circuit. Current can flow out of the power supply through both resistors in series and then come back out and return to the power supply. So let's turn on the power supply. It should hopefully still be at 0, and you notice there's no current flowing because there's no voltage. But remember that we have roughly average 440 ohms of resistance here. So as we start to turn up the voltage, we're going to start to see some current flow. The more volts, the more current. Okay, so very roughly this should be obeying Ohm's law, which says that the amount of current is the voltage divided by the resistance. Well, I can't do division with decimal numbers in my head very well, and I don't have a calculator handy, so very, very roughly speaking, let's just say that that's 500 ohms. Right, I just round it to 500 ohms, which is half of 1,000. So just doing the math in my head, very roughly speaking, whatever the voltage is showing, I should have twice that many milliamps, and that's what I've got. The milliamps position is the third one over from the decimal place, because milli means 1 over 1,000 or 1,000th, right? So what we've got here is 5 volts and roughly 10 milliamps. All right, and so that would continue. I can turn the voltage up, and you can see that keeps on following that. So it's a fairly linear response. It should be almost exactly linear. The only thing you want to do is don't turn up that voltage too far, because these are little resistors and they could get hot and they could either go up in smoke or cause you a nasty finger burn. So don't go over 10 volts on these and you should be perfectly safe. All right, so what are we going to do? I'm going to turn this back down to 5 volts. We have, it says in one of these next steps, it says adjust the power supply from 0 to 10 in steps of 2. Let the circuit stabilize for 5 seconds, and then record a bunch of stuff, which is the power supply voltage display and the voltage across each resistor. So we're gonna start at 0, and if we follow the instructions, what we would do is come over to our meter, measure voltage. Remember to set this back over to voltage. I always encourage you to use the lowest voltage setting. Use the lowest voltage setting that will not give you an overload reading. So for 0, really what we could use is the 200 millivolt setting. That's the lowest voltage setting. We don't expect any voltage at all. So we could set it down there. Of course, we have to turn the meter back on. 2 pushes on the yellow button. And then we should be able to come back over here and measure the voltage across each of these resistors. Now, this is kind of an exercise in futility because of the fact that we've got 0 volts applied. We know we're going to get 0 on the display, right? Now that doesn't look like 0, does it? It looks like 2.1 with a negative sign. But notice the display says millivolts. All right, so this is way, way down in the noise. And any noise any stray electrical noise, like from the lights and so forth, that are in the room are going to be picked up on these probes. So that's as good as 0. You might as well say that's 0 volts, even though it doesn't look like exactly 0. Anyway, just to be a faithful data taker, go ahead and record whatever the meter reads, including the sign, and write that down in your data table. All right, and you do the same thing for the other resistor. You measure across it. And let's see, I've got this kind of cobbled up here, but you can see it's about the same. All right, and then you can come back here and you can see the voltage is 0. You can see the current is 0. And then what the table wants you to do, or what the lab write-up wants you to do, is to just go ahead and do this 2 volts at a time. Now at 2 volts, we can't use the 200 millivolt scale anymore because we're expecting the voltage to be at least 2 volts. In fact, we really can't use 2 volts. We can try, but if the voltage is any greater than 2 volts, it's not going to work. So I'm going to try to finagle this so I can stick the probe in. You're going to be doing this with 2 hands, so you'll have a lot better luck. Let's see. All right. So the display says 2 volts. What I'm reading over here is less than 1 volt. So why is that? Well, it's because we have 2 resistors, and the voltage and the resistors are equal, so the voltage is going to divide roughly equally between them. In fact, it's called the voltage divider law. The truth is the voltage is going to divide proportionally. Whichever resistor is bigger is going to get the larger share of the voltage. The smaller one gets the smaller share. But those 2 readings should ideally add up to the 2 volts that's being displayed here. So this is negative 0.947, which brings up a good point. If you look at how I put my probes down, I didn't think very carefully about it. I've got the red probe at the lowest voltage because that's connected to the power supply negative. I've got the black probe on the other side. So that's correct. That negative sign is telling me the polarity of the voltage. Now, I didn't do anything wrong. It's not like I messed anything up. But if I switch the probes around, that negative sign goes away. So what the meter is doing is it's telling you the polarity of the voltage that's being read. And so that's 0.947, and then we should expect that the voltage on the other side, the other resistor, because it's, if you remember how we measured it, it's actually bigger. So we should expect that to be more than 1 volt, and it is. So you can see if you add that to the previous reading, hopefully that would add up to 2 volts. We're very close to it. Again, everything, this is an experiment, this is a lab experiment. Nothing's going to come out exact or precise. So there's always going to be some experimental error, something in the hundredths place. But if you get way off, then you've got to stop and ask, maybe my circuit's not hooked up right, maybe I'm not measuring correctly, or something like that. So try to figure it out, and if you can't, ask your TA and make sure you get the values recorded that you need to. All right, I'm going to stop this and we'll go on to the next part of the experiment.